Hey students, this is lesson 4.7. In this lesson, we're going to learn how to identify congruent overlapping triangles and to prove two triangles are congruent using other congruent triangles. Go ahead and do the review. I'll check back with you. All right, sometimes you can use common parts and reflexive property to help prove things. So it's good if you recognize the common parts. And if I were to draw these separately, so here's one triangle, and here's another triangle, you will notice that I drew the line WX twice. So that's the common part there. All right, you try that. All right, so we're going to use the common parts to help us prove two triangles are congruent, or parts of triangles are congruent. In this problem, we want to prove that angle T is congruent to angle U. So if we could show that the two triangles are congruent, then we can use CP, CPC to show that the parts are congruent. And I think what we're going to do here is, since these are right angles, our plan will be to use the HL theorem, because we have two right triangles. And then we'll use CP, CPC to show that these two angles are congruent from those two right triangles. So to use the HL theorem, we have to show that that we have right triangles, that we have a leg that's congruent, and that we have a hypotenuse that's congruent. So I'm going to set that up here. You can go ahead and try that also. All right, so I have my givens. So from my givens, I get that the triangles URS and triangle TS are right triangles. And that's just by the definition of a right triangle. And then I need, and I have RT is congruent to US. So that's the hypotenuse. So I just need one leg that's congruent. And you can see that if I drew out these two triangles, that one and this one, I have a common side that's RS. So we can just say RS is congruent to RS, and that's by the reflexive property of congruence. And then, since the two triangles, now we can say that the triangle URS is congruent to triangle TSR, and that's by the hypotenuse leg theorem. And then I can certainly say that angle T is congruent to angle U now, and that is because of corresponding parts of congruent polygons are congruent. All right, you try one. I think I'll just talk you through this quick here. So we know that triangle ACD is congruent to BDC. That's this one. And this one. And what we want is CE is congruent to EP. And what I'm thinking here is, if we could show that this angle is congruent to this angle, then we know that that's an isosceles triangle. And then by the converse of the isosceles triangle theorem, we can show that CE is congruent to ED. So go ahead and fill in the reasons. the proof you just did was kind of a long way to do it. You could just show angle BCD is congruent to angle ABC, and that's by corresponding parts of congruent polygons are congruent. And then from that, you can show that CE is congruent to DE because you have an isosceles triangle, because those two angles are congruent, so you have an isosceles triangle, and then by the converse of the isosceles triangle theorem, you can show that CE is congruent to DE. All right, so we're going to do a proof here where we use two pairs of triangles to help us prove that AS is congruent to LS. Notice I got rid of my diagram there. I'm going to just do a two-column proof for this one. So we can set it up here. A couple things you need to know here. Part of what's given that angle A is congruent to angle L. It's not listed here. And we can just get rid of this line. We don't really need it. So then we can call it angle A and angle L. So I'm going to set up my two-column proof here. Okay, so here's going to be my strategy. We want to show AS is congruent to LS. So that's these two here. And they're part of the triangles APS and LIS. So what I'm going to do is show that those two triangles are congruent first, and then I'll use corresponding parts of congruent polygons are congruent to get the triangles congruent. Now to get that, notice we are already given that angle A is congruent to angle L, and also we know that those two will be congruent by vertical angles theorem. So I just need to show that something else is congruent. What I'm going to do is show that that side is congruent. So I'm going to use angle side there to show the two triangles are congruent. To do that, I'm just going to start by saying AP plus PR is equal to AR, and LI plus IR is equal to LR, and that's just the segment addition postulate. And we're given that AR is congruent to LR, and so that means AR is equal to LR. So that was given, and by definition of congruence, AR is equal to LR. Well, if AR is equal to LR, then AP plus PR is equal to LI plus IR. And we also know that another thing that was given is that PR is congruent to IR. And so PR is equal to IR by the definition of congruence. And we have that there. So we're just going to subtract those equal parts on, and we get AP is equal to LI. And that means that AP is congruent to LI. And we now have those parts of the segments are congruent. So to finish two triangles, APS and SIL are congruent, we'll just show that the two angles now, and that's angle A is congruent to angle R. And that's given. I should fill in some of these reasons. So we have angle A is congruent to angle R. We also have angle PSA is congruent to angle ISL. And that is the vertical angle theorem. And so we have triangle PSA is congruent to triangle ISL, and that's angle side. And so then the parts are congruent, so segment AS is congruent to segment LS by corresponding parts of congruent polygons are congruent. All right, you try that. All right, separating overlapping triangles. Again, I'm going to get rid of this diagram because I'm just going to do a short 2-column proof. Okay, here's my plan. I can see that AB is congruent to AB because they share that. So we got that, right? And I also know that this is congruent to that. Well, what that tells me is that that's an isosceles triangle. So that means this angle, which is this angle, is congruent to this angle, which is this angle. So we have ABD, and then I need one more thing is given, and that's that angle C is congruent to angle B. So we have that. So we have angle side that those two triangles are congruent. And that's the way we're going to do it. So we're going to use the isosceles triangle theorem to work this out. So, column proof. I'm going to set up my givens here. So we have AB is congruent to BE. That's given, and angle C is congruent to angle D. And we need to show that also AB is congruent to AB by the reflexive property. And the other thing we're going to say is that angle ABD, or ABC that is, angle ABC is congruent to angle EAD. And we're going to say that is because, maybe I should put this ahead, we're going to say triangle ABE is isosceles, and that's from the definition of isosceles triangle. And so angle ABC is congruent to angle BAD, that's by just the isosceles triangle theorem, ITT. And then from that, we can say that since we have an isosceles triangle, we can say that, or we have that angle, and we have a side, another angle, angle C and angle D, and then the side AB. So by angle side, we have triangle ABD is congruent to triangle BAC. All right. All right, that's the end of the lesson. Go ahead and do the lesson check, and I'll see you next time in class.